Hi everyone. Today we're talking about solving equations. So to solve equations, we have to use inverse operations. Inverse operations are operations that undo each other. So usually you learned them in pairs. First you learned how to add, then you learned how to subtract, since they kind of go together. First you learned to multiply, then you learned to divide, since they go together. So we think of those as inverse operations. They undo each other. So when we talk about solving for an equation, we want to isolate the variable, which sounds complicated, but all that means is just get the letter by itself. So I always think about kind of like at a fancy restaurant, how you have to work your way in with all the utensils. Same thing with these, you have to kind of work your way in to solve for x. So the directions here say to solve the following equation for x, round to the nearest tenth whenever our answer doesn't come out nice and pretty. And that's okay. Sometimes they don't come out perfectly. That's all right. So first we have 3x equals 15. So 3x, what the heck does 3x mean? So that's really 3 times x, right? So those are being multiplied. And we know that to undo multiplication, we need to divide. So I'm going to divide by 3 on both sides. Over on the left side, 3 divided by 3 equals 1. So that's why they divide away. And I'm just left with x over there. Oopsies, let me pull myself up into the corner a little bit. There we go. Now you can see what I'm writing. Okay. So those 3's divided away to 1, so I just have 1x. And then I'll take 15 divided by 3 and get 5. So now that my variable is isolated, I have just x on one side and I just have a number on the other. I'm done. X equals 5. Okay, now I have x plus 10 equals 15. So I'm adding here. So to undo addition, I have to subtract. Now, one thing I probably should have mentioned earlier is that every operation that you do, if you do it to one side, you have to do it to the other. I call it the golden rule of algebra. Do unto one side as you do unto the other. You have to keep the scales balanced. So if I want to subtract 10 from this side, I have to subtract 10 from this side as well. I have to keep it even. So let's take a look at that. 10 minus 10 is 0. So x plus 0 is just x equals. And then we have 15 minus 10 is 5. So now that we have our variable by itself, we're done. Okay, let's look at the next one. Now we have x over 5 equals 14. So that fraction bar actually means divide. That's where the division symbol actually came from. There's a line with a number on top and a number on the bottom. That's where the division sign came from, is fractions. So right here, I know x is being divided by 5. So to undo division, I have to multiply. So I'm going to have to multiply both sides by 5. Now over on the left side, 5x divided by 5, the 5's divide away to 1, and we're just left with x. On the right side, we have to figure out what 14 times 5 is. So pop that in your calculator, and we are going to end up with 14 times 5. 70. Good deal. All right, now on these next ones, we have a few more steps we have to go through. So, what do you think I have to do with my 10 first? Go through and do that real quick. So hopefully just now you were able to, there we go. You recognize that you need to start getting x by itself. So you decided to add 10 to both sides. We're going to work our way into that x. We're going to get rid of that 10. So these 10s add to 0. Negative 10 plus 10 is 0. So 7x plus 0 is 7x. And over on that other side, we have 11 plus 10, which is 21. What's the next operation? What do we have to do to get rid of that 7? So yeah, we need to divide by 7 on both sides. These will divide away to 1, so I'm just left with x. And then 21 divided by 7 is 3. All right, now this one is kind of tricky. So negative 9 and 2x are being added together, right? So the way that I want you to think about this is not necessarily as inverse operations, but think about as adding to 0. So earlier, like in that x plus 10 equals 15 problem, we subtracted 10 from both sides to get x by itself. And that was because positive 10 minus 10 is 0. So we wanted to get to 0 there. And that's what's happening here. We want to get to 0. What can I add or subtract from negative 9 to get to 0? Yeah, I can add 9. Put plus 9 on this side. And the golden rule of algebra, do unto one side as you do unto the other. So negative 9 plus 9 is 0. So I'm just left with 2x on that side. And then 17 plus 9 is 26. Now, 2 and x are being multiplied. So to undo that multiplication, we'll divide. So I'll divide by 2 on both sides. 2x divided by 2, those 2's divide away to 1. So x equals, and then 26 divided by 2 is 13. What do you think the first step is on our next problem? X over 9 minus 6 equals 1. What's the first thing we should do? All right, so the first thing that we should do is add 6 to both sides. So those 6's will add away to 0. So we're just left with x over 9 equals, and then I have 1 plus 6, which is 7. Now x is being divided by 9. So to undo that division, we're going to multiply by 9 on both sides. These 9's divide away to 1. 9x divided by 9 is just x. And then 7 times 9 is 63. This next one might feel a little bit strange since your x is on the other side. That doesn't matter, though. I know you might have been taught once upon a time that your x always has to be on your right side and all of your numbers are going to be on the left, or vice versa. It does not matter which side what is on. You just want to get your variable to one side and plain old numbers to the other. So with negative 8 equals 17x plus 9, I'm not going to move the x around. X is already on the right side. So I'm going to go ahead and get rid of that 9 and bring him to the other side. So since I'm adding 9, I'm going to have to subtract 9 on both sides to get rid of him. So negative 8 minus 9 is negative 17 equals. These 9's add to 0. So 17x plus 0 is 17x. Now 17 is being multiplied by x, so to undo that multiplication, we'll divide on both sides. Divide by 17, divide by 17. These divide away to 1, so we're just left with x. And then we have negative 17 divided by 17 is negative 1. So x will equal negative 1. Okay, what do you want to do on this next one? So there's a couple of different options. Some of you will want to subtract 7x to the other side. Some of you will want to subtract 32 to the other side. Here's the good news. As long as you're adding and subtracting the same thing on both sides, you're fine. As long as you are solving just the way that we were explaining, you're going to get the same answer. So let's say that we're going to go ahead and bring the x over to the other side. So let's subtract that 7x since he's positive. 0 minus 7x is negative 7x. 7x minus 7x is 0, and then I had plus 32, so that's 32. Now negative 7 times x, or negative 7x means they're being multiplied, right? So to undo that multiplication, I will divide by negative 7 on both sides. Now 7 doesn't go nicely into 32, so this is where I would go ahead and get out my calculator. So I'm going to go ahead and take 32 divided by negative 7. And when I do that, I'm going to get 4.571 blah, 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 right? Okay, now let's scroll up for just a second. It says that it wants us to round to the nearest tenth, right? To the nearest tenth. So what the tenth is it's 1 decimal place, okay? Just 1. And also remember that it says round. It doesn't say just stop writing after the first decimal place. Remember, you need to look at the number afterward. So let's go back down. That's where we were. So I went around to this digit right here. So looking at the next number, I have a 7. So that means I have to round up. The one larger than 5 is 6. So we'll end up with 4.6. And that will be my answer since it told me to round to the nearest tenth. All right, on the next one. What do you think we should do first? I think we should subtract 17 from both sides. So 17 minus 17 is 0, and I have a negative 11x over there on the left. And then 21 minus 17 is 4. Negative 11x means I have negative 11 times x. So to undo that, we need to divide by negative 11 on both sides. Those will add to, divide away to 1. So x equals. Now 11 doesn't go into 4, right? So we're going to have to put that into our calculator. So when I put 4 divided by negative 11 in my calculator, I get negative 0.3636 blah, blah, blah. Now, we already talked about how we wanted to round to the nearest tenth. So we need to look at the number after that 3. It's 6. So since that's larger than 5, I have to round up. I'm going to add 1 to 3, and that'll be negative 0.4. All right, how do you think we should solve this one first? What should we do first? So I would add 50 to both sides. (10 plus 50 is 60 equals negative 50 plus 50 adds to 0, and I'm just left with 6x over here. What do I do next? I'm going to divide by 6 on both sides. So we end up with 10 equals x. If that bothers you, are you allowed to set it equal as x equals 10? Totally. Absolutely. All right. See you guys later.